A critical value is a key threshold in statistical analysis that helps determine whether a hypothesis should be accepted or rejected. It is used in hypothesis testing to define the boundary between the region where a null hypothesis is retained and the region where it is rejected. The critical value depends on the chosen significance level, often denoted as alpha, which represents the probability of making a type 1 error, rejecting a true null hypothesis. When a test statistic exceeds the critical value, it suggests that the observed results are unlikely to have occurred by chance, leading to the rejection of the null hypothesis. The main purpose of critical values is to provide a clear decision-making criterion in hypothesis testing. They help researchers determine whether the results of an experiment or study are statistically significant. Without critical values, it would be difficult to draw conclusions from data because there would be no objective way to assess whether an outcome is meaningful or just random variation. Critical values are useful in fields such as medicine, economics, and psychology, where researchers need to evaluate the effectiveness of treatments, economic trends, or behavioral patterns. By establishing a threshold for statistical significance, critical values ensure that conclusions are based on reliable evidence rather than guesswork. Now let's look at the different types of critical values. One common type is the z-critical value, used in hypothesis tests involving the standard normal distribution, such as in z-tests. Another type is the t-critical value, which is used in t-tests when sample sizes are small and population standard deviations are unknown. The chi-square critical value applies to tests involving categorical data, such as determining whether an observed distribution differs from an expected one. F-critical values are used in ANOVA, analysis of variance tests, to compare multiple groups. Each type of critical value is selected based on the type of data and the statistical method being used. Now let's look at some examples of critical values in action. In medical research, a scientist testing a new drug might use a significance level of 0.05, meaning they accept a 5% chance of incorrectly rejecting the null hypothesis. If the test statistic from their experiment exceeds the critical value, they conclude that the drug has a significant effect. In quality control, a manufacturer might use a critical value to determine whether a batch of products meets quality standards. If a sample's defect rate is higher than the critical threshold, the batch may be rejected. In elections, pollsters use critical values to assess whether survey results suggest a true lead for a candidate, or if the difference is likely due to chance. Critical values play an essential role in statistics by providing a standardized way to assess the significance of data. They ensure that conclusions are based on objective criteria rather than subjective interpretation. By setting a threshold for statistical significance, critical values help researchers make informed decisions in a wide range of fields, from science and business to social studies. Understanding critical values allows for better interpretation of data, reducing errors, and improving the reliability of research findings.